When looking at the viral epidemic with mathematical modeling, there appeared to be certain mitigating factors involved. Early on, we found the segmented population dampening effect would reduce estimates due to a high at-risk segment. This has similarities to the SARS virus from 2002, another novel coronavirus. The big issues being its virulence and its newness. We have studied the data from Washington State, keeping both the governor and the president apprised of our research findings. We specialize in mathematical modeling projects, some of which designed to identify the meaning behind recent scientific discoveries. We have created some simple models evaluating the mitigating factors involved in this epidemiological crisis. It is our hope to look at things from a different perspective, and by showing these simple models to demonstrate the findings of our studies. This is a timely undertaking that may have some importance. The first thing we did was ask a few questions. What is mitigating the impact of this virus? Is the virus just weakening? Why is there a typically sharp decline at the end of this type of viral epidemic? The flux point showed where the vectors were changing. So some factor was causing this change, and we knew that it had to have something to do with an antibody effect. The first thing we did was create a viral infectivity rating. We wanted to create a chart to measure each infection based on the virus and the human being involved. We went from a weak infection to a strong viral infection. Natural population immunity. A percentage of the population may already be immune to a virus, so that mitigates the spread to a finite number. This would likely be from exposure to the SARS virus. It does not seem to be a viable factor in this case. Since this is a novel virus and studies have not reported anything about a population immunity. The next factor was the natural vaccine. Small doses of the virus spread to the population could be a mechanism for immunization from this particular virus. Every person in the population who's exposed to a small dose will have the time for the body to create antibodies to protect itself from this particular virus. The last factor we looked at was the antibody sharing model. We're speculating that antibodies can be shared between people as a natural mitigation factor. This is something that we've termed the collective humanity immune system. One person would get the virus healthy, and they would create antibodies within their system. Then when they go throughout the population, they will share these antibodies with other people through sweat and saliva. This is a novel approach, and we think there's merit behind it. It would be a naturally evolved system for humanity to share viruses and also share the antibodies to protect themselves from the viral infection. So the virus would infect the person, and then this person, if healthy, would eventually create antibodies to attack the virus. These antibodies would eliminate the virus for them, but also retain in their system. They would be able to share these with other people who would use their antibodies, and instead of creating new ones, they'd be able to replicate the ones that were shared with them to fight the virus. The issue with the novel coronavirus, COVID-19, is both its virulence and its novelty. It is a nasty virus that can viciously attack the lungs. Being new means each body must create and replicate a new type of antibody. When a novel virus infects the first few people in a population, a new type of antibody must be created to match the viral receptors. As it spreads, certain people develop strong antibodies in their system. If these can be shared through the population, it would have a beneficial effect. The new person's immune system could replicate these. It is important to identify these factors to develop a deeper understanding of what happens during a viral epidemic.